Okay, as I was saying, in this kind of problems, the ratio test is the best choice because, for instance, here our series is this, okay, and the an, the little an here is a n minus 1 x to n, okay, no, x to n plus 1, sorry. For instance, for a1 is a 0 x squared, okay. Now let's let's calculate this fraction for this. For this an plus 1, it is a n x2, here n plus 1, n plus 2, okay, this is an plus 1 over, and an is this, an minus 1, okay, and this is x2 n plus 2, this is x2 n plus 1, so that would be x, okay, and the limit of this should be smaller than 1, and if this is smaller than 1, the series is convergent, and so the limit of this as n goes to infinity, here x doesn't depend on n, so x is constant, x is not a constant, but with respect to n it is, or in regard to n it is constant, so the limit of this as n goes to infinity would be, we could take x outside, that would be equal to x times the limit of an over an minus 1, okay, and here from this recurrence relation, an plus 1 over an is equal to minus n plus 1 over n times n plus 3. I think in the previous video I wrote it as r plus 1 and r times r plus 3, which this is more correct. And let's calculate this fraction from this. Here this is an plus 1, and here we got n plus 1 in the denominator, so it should be equal to, let's write it here, it should be equal to minus n in the denominator over, and this is an, and here we got n times n plus 3. But here we got an minus 1, so in the denominator gonna have n minus 1 times n minus 1 plus 3, which is n plus 2 plus 2. Or, and, sorry, we should work with the absolute value. So the absolute value of this is positive, and the absolute value of this is this, okay? And the limit of this as n goes to infinity is 0, because the degree of this is 2 and the degree of this is 1, okay? And here x times 0 would be 0, so the series for every values of x is convergent. And 0 is smaller than 1, okay? That's why I said that this series is convergent, okay? So let's have another example. Let's check the convergency for this series. N to 4 over n factorial. And this should be from an infinite polynomial, in which x is 1. We want to check the convergency at x equals to 1. This happens in the power series, we call them the infinite polynomials, in which we know that this series, I talk about that in later videos, that we know that this series is convergent in some open interval, but we want to see that if the series is also convergent at the endpoints. For instance, suppose, our infinite polynomial would be in this form, the sigma n to 4 n factorial x to n, okay? And we want to, and x equals 1 is one of the endpoints of its convergency interval, and we want to see if it is convergent at the x equals to 1. So something like this, okay? Let's see that using the ratio test. an plus 1 over an. And this is positive, so this is not necessary. And what is an plus 1? It is n plus 1, 4 over n plus 1 factorial over an. An is this, n to 4 n factorial, and this is n plus 1 to 4 n plus 1 factorial times n factorial, this goes up, over n to 4. This is n plus 1 times n factorial. So these two would be like this, and n plus 1 here, n plus 1 to the 4 here, so they would be like this, and the ratio would be this over into 4. And the limit of this as n goes to infinity is again 0, because the degree of this is bigger than the degree of this, and the series, and 0 is smaller than 1, and the series is convergent.